Hello students, we are starting with Inter second year class 12 first chapter solid state part 1. Now let us start with introduction. Now in this chapter we will be discussing about matter. Okay, matter. What is matter? Matter is anything which has mass and occupies space. Okay, matter is anything which has mass and occupies space. And matter is basically divided into three types, that is solids, liquids and gases. You all know this. Okay, now in this chapter we are going to deal with the solids in detail, and before starting that we have to study about characteristics, that is properties of the solids. Below are some of the important properties of the solids. Okay, solids have fixed mass, interparticle distances are short. We already discussed what is interparticle. It is nothing but intermolecular or interatomic or interionic. These distances are short, that is, they are closely packed. Next point, solids cannot be compressed much. Why? We have already discussed that they are closely packed. So there is no space between particles. So you cannot compress much. And hence they are rigid. They are tightly packed. Next point. Particles occupy fixed positions. So each particle has a fixed position. But they can only oscillate about their mean positions. Okay, they have fixed positions, can only oscillate about their mean position. Now, to understand solids, we have to discuss some of the important terms. Okay, now solids are basically divided into two types: crystalline solids, amorphous solids. Okay, solids are divided into two types: crystalline and amorphous solids. What are crystalline solids? Solids which have highly ordered periodical repeating arrangement of particles in three dimensions forming lattice are known as crystalline solids. That means you take the case of crystalline. Here in this picture, first picture, you can see quartz. Here there is regular arrangement of particles in all the directions. Okay, regular and repeating arrangement in three dimensions. Okay, which forms a lattice. Examples are diamond and quartz. For that matter, most of the solids come under crystalline solids only. Next comes the amorphous solids. Amorphous. What do you mean by amorphous? Amorphous means no form. In Greek, amorphous means no form. So, we already discussed that solids are divided into crystalline and amorphous. Here, any non-crystalline solid will come under amorphous solid. So, any non-crystalline solid in which particles are not arranged in regular lattice pattern come under amorphous solids. Example, gel, glass, plastics, rubber comes under this category. Okay, these are crystalline and amorphous solids. Next term, long range order. We come across these words, long range order and short range order. Okay, we come across these terms, long range order, short range order, when we are discussing about amorphous and crystalline solids. What is long range order? This is a regular pattern of arrangement of particles which repeats periodically over very long distances. This periodical arrangement is not only restricted to some place, it is found over the entire crystal. Okay, that is long distance over the entire crystal. Okay, then it is called long range order. This regular pattern of arrangement of particles which repeats periodically is seen throughout the crystal. Okay, in case of what is short range order? Regular and periodically repeating pattern, okay, which is observed only for small distances in the solids, as in the case of amorphous solids, is known as short range order. That is regular periodically repeating pattern observed only for small distances, as in the case of amorphous solids, is called short range order. Now next term is pseudo solids or super cooled liquids. Amorphous solids are known as pseudo solids or super cooled liquids. Pseudo means what? False. Solids. Why they are called pseudo solids means there is no proper arrangement of particles, as in the case of amorphous solids. Okay, that's why they are known as pseudo solids, or after cooling liquids to very low temperature solids are formed. Like that also you can understand. So pseudo solids or super cooled liquids are nothing but amorphous solids, and they have tendency to flow. Okay, even though it is very slow, they have a tendency to flow. Now we will discuss about anisotropy and isotropy. What is anisotropy? If you observe crystalline solids, okay, some of the physical properties you can say, like speed of light, bending of light. Bending of light is nothing but refractive index, and electrical resistance show different values in different directions in the same crystal. If you observe these two lines in the crystalline SiO2, that is quartz, each line having different pattern of arrangement of particles. So in one line the physical properties may be different because the arrangement of particles is different. In another line arrangement of particles is different, so the physical properties values may be different. Even though they are regularly arranged, in one direction there may be different arrangement, and in another direction there may be different arrangement. Okay, suppose in x direction there may be different arrangement of particles, and in y direction there may be different arrangement, and in z direction there may be different arrangement of particles. Okay, you can take the example of the first picture. This is anisotropy. Okay, anisotropy is nothing but the physical properties like speed of light, bending of light, electrical resistance have different values in different direction in the same crystal. Okay, next comes the isotropy. Isotropy is observed in amorphous solids. Here value of physical properties like bending of light, speed of light, electrical resistance are same along any direction. Why they are same? Because in any direction, in case of amorphous solids, there is irregular pattern of arrangement of particles. So you can take any direction, there is always irregular pattern. So in x direction you go, or in y direction you go, or in z direction you go, there is always irregular pattern. So because of this irregularity, in any direction you go, the properties will be having same value. Okay, as in the case of amorphous solids. Next, we will discuss about the crystalline and amorphous solids differences. Okay, this is a chart discussing about crystalline and amorphous solids. Now, if you take the structure of the solids, crystalline solids have definite geometrical structure, whereas amorphous solids have no definite geometrical structure. Okay, crystalline solids have definite geometrical structure, amorphous solids have no definite geometrical structure. When you come to the nature of solids, crystalline solids are true solids, whereas amorphous solids are pseudo solids or super cooled liquids in nature. Okay, next, crystalline solids have long range order for particles. We already discussed what is long range order. Regular repeating pattern of arrangement of particles over long distance. Okay, whereas in amorphous solids only short range order is absent. Other points we will discuss. Crystalline solids have anisotropy. What is anisotropy? We already discussed. Except in cubic crystals. Cubic crystals have isotropy. In any direction they have same values. But in case of other solids, physical property values depend on direction. Whereas you take amorphous solids, they are isotropic in nature. Physical property values will be same. You take in any direction. Does not depend on the direction, because you go in any direction, they are all arranged in a irregular manner. Now, when it comes to the cleavage property, crystalline solids, when cut with sharp tool, they split into two pieces with plain and smooth surfaces. Whereas amorphous solids, when cut with sharp edged tool, they get divided into two pieces with irregular surfaces. Melting point. Crystalline solids have sharp melting point. That is, you give a particular temperature, they start melting at that particular temperature. But amorphous solids will not melt at a particular temperature. They will melt over a range of temperature. Okay. Next, definite and characteristic heat of fusion. Okay. Crystalline solids have definite and characteristic heat of fusion, but amorphous solids have no definite characteristic heat of fusion. Heat of fusion. It is the quantity of heat necessary to change 1 gram of a solid to a liquid with no temperature change. That means solid phase is getting converted into liquid phase, but there is no temperature change. So in case of amorphous solids, there is no definite heat of fusion, but in case of crystalline, you have definite and characteristic heat of fusion